Good evening. Let me explain to you really fast what about the thing we did today in class about a inverse, the other way to find a inverse. And here you have this PDF. I will share this with you. But the main idea of finding a inverse is basically finding the following this definition. So this is my definition now. They're saying here, given A, its inverse is given by A inverse equals 1 over the determinant of A times the adjoint of A, where DET of A is the determinant of A and ADJ A is the adjoint, right? And this is just properties we covered many times in class, right? About A times A inverse or equals A inverse times A. That will give you the identity matrix. You know that. So the main thing about this is once if they give you a 3 by 3 matrix like this one, in order for me to find the inverse, I have to use the definition that they give below, right? So, but before I do this, finding the inverse for a 3 by 3 matrix, I want to show you something. I want to show you like how to do a 2 by 2, right? Find the inverse of a 2 by 2 using this formula. So for instance here, right? If I give you an example, I have 2, 3, 4, 5. The first thing I need to find out is if this matrix of 2 by 2 has an inverse or not, right? If it does, then it's invertible. If it doesn't, then that means it's singular, and I don't want that situation, right? So the determinant of A, you know how to calculate. This is the formula, right, from the past. Let me put that here. This is formula. So the determinant of A is just AD minus BC, right? So you can compute that, and when you compute that, you get -2, right? So that means that this is non-singular, right? Non-singular. So that means it's invertible, right? And invertible means it has an inverse, right? Therefore, you can say, I need to find A inverse. So the inverse formula is the same, 1 over the determinant of A times the adjoint of A. However, the adjoint of A, it's really easy to find for a 2 by 2. The only thing I need to do is replace, well, basically switch the positions of the entries in the matrix, right? So I can switch, for example, I have AD, so I switch those two, so that would be DA, and then I change the sign for B and C for their opposite, right? So in this case, we have 2, 3, 4, 5. I need to switch those. You see, I switch here the position of 5 and 2, right? Because we originally in matrix A is 2, 5, so I switch that to 5 and 2. And for this position here, -3 and 4, I just changed the sign of the original numbers, right? Before it was 3, now it's -3, and then 4, then it's -4. So once you do that, then you can compute the determinant of the adjoint of this, right? So this is the adjoint basically. You already have it. So this is the adjoint of A. Now to find the determinant, I'm sorry, to find A inverse, you need to find the determinant, right? Which we already did. So that's -2. So the formula said 1 over the determinant of A, which is -2. So 1 over -2 times the adjoint matrix, which we already calculated. And then you need to compute, right? You need to solve this. So when you compute this, you remember when you're multiplying an element or a number by a matrix, that means every entry is multiplied by that number. So this is -5 halves, and this is 3 halves, and this is 2, and this is -1. So this is A inverse. If it is, when I multiply by matrix A, it should give me the identity. And in fact, that's what it does, right? So if we do the dot product, we have 2 times a column 1 or row 1 by column 1. If you do that computation, you get 2 times -5 halves plus 3 times 2. This is -5, and this is plus 3, that's 1, right? 95 plus 6 is 1. So that's the first computation. The second one should be row 1 by column 2. You do that, same thing, 2, 3 halves, right? You should get a 0 this time, plus 3 times -1. So you get -3, this is 3, you get 0. So that's what it is, right? and you keep doing the dot product like one more time, right? For the row 2. So you do this row 2 by column 1. Again, you get the same thing, right? So this is 4 times 95 halves plus 5 times 2. You should get 0. So this is negative 5. Actually, this is negative 10 plus 10. That's 0. And then you do the same for the last column, right? Row 2, column 2. And that will be 4 times 3 halves plus 5 times negative 5. So this is supposed to give you 1. So this is what? 6 minus 5, that's 1. So indeed, you get the identity. That's the point, right? So I already showed you that how to compute the inverse of a 2 by 2 just using the adjoint formula. Okay, there's another formula I want to talk about before I continue. If I want to find not using the adjoint, if I want to find the inverse of A, so the A is, this is a matrix, right? 2, 3, 4, 5. If I want to find the inverse of this, there's another formula, 1 over AD minus BC times, well, you know that this is A, B, C, D, right? So you basically do the adjoint. So you change this D with this A, and you change, and you just do the same thing, right? You put the negative or the opposite of those, the sign or opposite to those values, right? For negative B and negative C. So this is formula. Let's see if that turns out to be the same, because we already have the inverse of that, right? So they're saying here A inverse is 1 over AD So AD is what? 10 minus BC. BC is just 12, right? And this is D would be 5, and then this will be 2, and this is negative 3, and this is negative 4. Let's see. So this is 1 over negative 2 times, well, each element in the matrix, right? Each element here. So let's compute this. A inverse is negative 5 halves, right? 85 halves, 3 halves, then we have 2, and this is negative 1. Done. It's not the same? It is the same. So you can use this formula too. I don't know if this one you like it more, whatever it's easier for you, you use it. Okay? So that's another formula. But in reality, that's just a determinant, right? Isn't it? It's not the same. So it's the same, right? Because that, but they don't mention in class these in school these things. So this is the adjoint, and this is the determinant of A if you really think about it, because AD minus BC is just the determinant of A, right? But some people, they just don't think about that way. They think this is the same thing, right? But this is more straightforward, I guess, for students, because they don't want to remember what's the adjoint or whatever. So that's how you can do that. That's another, most textbooks, they have written this inverse in this form. Okay, I just want to point that out. Now, let's go back to the main problem, right? The main problem is when we have a 3 by 3 matrix, right? So how can we do this? This is the definition, right? This is the definition. A inverse is 1 over the determinant of A times the adjoint of A. So what that means, the adjoint of A? First of all, I need to find the cofactor of each element in matrix A. So how can I do that? I already make this I already do each element for each cofactor, right? So we need to find the determinant of each of these, right? How I do that? Let me start from scratch this thing, because I don't want to confuse you. I know it's long, but I want to cover, because after that you don't know what to do. Let's see. Let me start from scratch, because this is the thing that you need the most help, I'm pretty sure. Okay. So let's follow the definition, right? I'm gonna keep this because this was my answer before, just in case I did something. I would, if I do something wrong, I know I can check with that. So again, you need to find a cofactor of matrix A. The cofactor of matrix A means this thing. What is the cofactor of 7? So you do column 1, row 1. So you do the cofactor of 7 will be 3, -1, 4, -2. And this sign means this is plus, right? Following the little trick that we memorize or something. Now, for this second, it would be negative, right? So let's do that. If we do that, we get this. 0, -1, -3, and -2. So this is the cofactor of 2, right? Just remember, I just want to make sure that you understand this. These are the entries, right? A11, A12, A13. What that means, row 1, column 1, row 1, column 2. So the first entries, we can call it IJ, where I is the rows and J are the columns. So you can do that if you want, right? If it's easier for you to remember. So row 1, column 1, row 1, column 2, row 1, column 3. And then this is A21, A22, A33. I'm sorry, A23, A23. And then you have A31, A32, A33, right? That's a way you can remember these things. Okay. So we're doing the cofactor of 2. We already did it. So this is plus. Let me move this here. And then we have to do for this one, right? What is the cofactor of of 1 is 0, 3, -3, and 4. So let me copy these things like many times, so I don't need to keep writing this. Copy, paste. Okay, let me copy that one more time. Let me erase these values. Okay, so that would be much easier than me keep doing these things. Okay, so what's next? We need to do the cofactor of what? Of 0, right? So the cofactor of 0 is this. So this is 2, 1, 4, -2. What's next? The cofactor of 3. What's the cofactor of 3? Right? It's 7, 1. Then we have -3 and -2. What is the cofactor of -1? The cofactor of -1 is 7, 2, -3, and 4. Now I need to put the sign, right? So this is negative, this is positive, this is negative. What about what is the cofactor of -3? I'm talking about row 3, right? Cofactor of -3 is 2, 1, 3, -1. Then what is the cofactor of 4? Well, the cofactor of 4 is 7, 1, 0, -1. What is the cofactor of -2? The cofactor of -2 is 7, 2, 0, 3. This is what? Plus, minus, plus, right? Let me put that minus here. So now we need to compute, right? So this is what? The first one is 3 times -2. We're doing the determinant of each of these, right? So 3 times -2 is -6 minus 4, that's gonna be -2. So that's the first element. So I write it already. So if you do for the second one is 0 times -2 is 0, minus 3 is -3, but because of the sign outside, it's +3. Then 0 times 4 is 0, minus 9 is going to be +9. So that's right here. So I already did these two. So let's do for the row 2. So -2 times 2 is -4, minus 4, that's -8. And if you add the negative outside, that would be +8. And then after that, you do 7 times -2 is -14, minus 3, that's going to be +3. So this is what? -11, right? So that's right here. We already compute these two. 7 times 4 is 28. 28 minus 6 is 34, but you have the negative outside, so that's going to be -34. Then let's do for this one. So 2 times -1 is -2, minus 3 is -5, so that's right here. Then 7 times -1 is -7. With the negative outside, that's going to be +7. And the last one should be 21, right? That's just 21. So this is the cofactor matrix, right? This is the cofactor matrix. And the only thing to do, or what's left, is you need to do the transpose of this. The transpose of the cofactor matrix gives you the adjoint matrix of A. So once you find the cofactor matrix, you have to do the transpose of that. So what's the transpose of matrix C? Well, that's very easy. Change column 1 to, so the column 1 becomes row 1. So this is -A, -2, A, -5. Then you have 3, -11, 7. This is 9, -34, and 21. Okay. So this is the transpose of that. And we said that the transpose equals to the adjoint. So the only thing I need to do left is find the determinant of this matrix, right? Which I didn't do yet. Okay, so I'm talking about the original matrix, right? If you forget or you got confused, use the definition of these formulas, right? So I need to do the determinant of A. So this is what? Use Sarus, right? So 7, 2, 1, 0, 3, -1. Do this matrix of operation, right? So this is this times that times this. And you have to recall that Sarus method is what? The determinant, in this case of A, equals the major diagonal minus the minor diagonal, right? So you might know how to do that already. So this is what? -42 plus 0, and then this is +6, right? Minus, and we do the minor diagonal, so this way. So if we compute this, what do we have? So this is -9, this is -28, and that's 0, right? So this is what? -36 minus, this is 37, right? But it's negative. So that's going to be positive. So that's just going to be 1. So this is the determinant of A equals 1. Again, what's the definition? A inverse equals 1 over the determinant of A times the adjoint of A, right? So we have everything that we need. We just need to compute, right? So 1 over 1, so that's not going to change anything. So what's the adjoint of A? Well, this one is the adjoint of A, this transpose. That was here, right? So we need to multiply these things, right? So if you multiply, remember, you need to multiply, this is 1. So that's not going to change anything, right? So that's going to be A inverse is this thing. Done, right? So this is the answer. This is the answer. Now, how I check if I right or wrong? You have to multiply A times the A inverse, right? So let's check that. We have to use the dot product, right, to check. And we have to make sure that the dimensions, they match. They don't match, then we have a problem. So we have A inverse here. And I need to find A, the original matrix. So this is A. So if I multiply them and they give me the identity, that means I did it right. If not, I make a mistake. So A times A inverse equals the identity, right? So let's see if this is true. 1 0 0 0 1 0 0 0 1. So let's do the dot product. This row 1, column 1. 7 times -2 plus 2 times 3 plus 1 times 9. So this is -14 plus 6 plus 9. This is 15 minus 14. That's 1, right? So that's right. So you have to do now, you have to do row 1, column 2. Compute. So 7 times 8 plus 2 times -11 plus 1 times -34. Compute. So this is what? 56 minus 22 minus 34. If you combine these two, you get 6, 56. And this is also 56. So this is 0. So that's right, right? You keep computing. Now we have to do row 1, column 3, right? I think you get the point. I will stop at this because you can just calculate that after that by yourself. So this is 7 times 85 plus 2 times 7 plus 1 times 21, right? So this is 180 plus 14 plus 21. So this is 35 minus 35, that's 0. And let's do everything because I want to make sure that you understand. So now I have to do row 2, column 1. So this is 0, 9, right? Plus, let's see, 0, 9. Let's do step by step. 0, 9 minus 9. So that gives you 0, 2. So that's right, right? This element is here, there too. What's next? Row 2, column 2. 0 times 8 plus 3 times -11 plus -1 times -34 goes away. -33 plus 34, that's 1. That's right. Next, this guy, row 2, column 3. So this is 0 times 85 plus 3 times 7 plus 81 times 21. Compute. 0, 21 minus 21, that should be 0. So that's right, right? So we already showed these 3 things. Next. Now, row 3, column 1. Compute. So this is 6 plus 12, and this is -18. So that's 0. And that's what you have here, right? So that's good. Next, row 3, column 2. Compute. So this is what? -24 minus 44 plus 68, right? So you compute this and you get -68 plus 68, that's 0, that's right, right? So that was this entry right here. And then the last entry should be row 3, column 3. Let's see if that's true. So this is what? You should get a 1 now. So this is 15 plus 28 minus 42, right? So when you multiply these things, you get 43, right? Minus 42, that's 1. So that's right. Easy, right? So now you know how to find the inverse using the adjoint. And basically we have to apply everything that we learned in the past, right? Like the determinant, the, using either the cofactor or Sarus or whatever method you want. And let's see, we have to do matrix multiplication, which is basically the dot product, right? But before you even try to attempt that, you have to make sure that A inverse exists, right? If it doesn't exist, then you will have a problem, right? Okay. So that's basically most of this video, right? So I show you how to find the inverse of a 2 by 2. I show you how to find the inverse of a 3 by 3. And the next step will be solving for ax equals b, which basically we need to multiply both sides by the inverse, and we have x equals a inverse b, right? So that would be how can you find that, right? So we can try, if you want to do that, we can try one. So let's see this one that they want us to do that, right? Okay, let's do that. So this is a system of equations. The first thing I need to write is as a matrix, right? So this is 7, 2, 1, 0, 3, negative 1, negative 3, 4, negative 2. So this is A, right? This is, remember, this system is A, and X will be X, Y, Z. This is a vector. This is a matrix. It's a vector. And this is another vector. 21, 5, 81. And we call this B, and we call this X hat, and we call this A, right? So AX equals B. So how can we do this thing? The first thing we need to do, if we're doing that way, the inverse way, we need to find the way we learn it, right? So let's do the way we learn just today. So A inverse, the definition is 1 over the determinant of A times the adjoint of A, right? So we need to compute the adjoint of A. That's the annoying part, right? Or the part that makes you the most tired, I would say. So let's calculate. We need to find the cofactor matrix, right? So let's do that. How can you do that? Okay, so let me, we can do that right here, right? So this is, let me copy these things. So remember, this is plus, minus, plus. So what is this? So what is the cofactor of 7? You do this. The cofactor of 7 is 3, negative 1, 4, negative 2. You do now, what is the cofactor of 2? The cofactor of 2 is 0, negative 1, negative 3, and negative 2. I should not do that. Okay, doesn't matter. Okay. What is the cofactor of 1? The cofactor of 1 is 0, 3, negative 3, 4. So let's, we have to do this 9 times. I should not do that. Okay. Okay. So now I have to erase it. Okay, that's fine. It's okay. Just watch out with the signs, right? If you messed up with the signs, everything is wrong. Okay, so let me write that here. Okay, let's compute this. So we have 3 times negative 2 is negative 6. Negative 6 minus 4, negative 6 plus 4, negative 2. So that's the cofactor of 7, negative 2. Now for the next one, you do the determinant, right? So this is 0 minus 3. That's going to be negative 3, and that one is going to be positive 3. And you may say, how you did it? I did this. 0 minus negative 3 times negative 1 is positive 3. So this is negative 3, and negative 1 is positive 3. That's how I get that. The next value should be what? The next value should be 0 times 4, that's 0, right? 0 minus negative 9. All right, so that's going to be positive 9. So this is 9 now. Next. Next, I need to do, what is the cofactor of 0, right? So I need to erase this. Cofactor of 0. So cofactor of 0 is 2, 1, 4, negative 2. Remember, this is minus, plus, minus, right? So when you compute this, you get negative 4 minus negative 4. So that's positive 8, right? Because of the sign outside. Okay, so what's next? So this 8 represents the cofactor of 0. So what's next? Next, it will be the cofactor of 3, right? is the cofactor of 3. So this is what? 7, 1, -3, -2. So you need to compute this. What do you get? -14 minus -3. -14 plus 3 is -11. So this is going to be -11. X. We need to do the cofactor of -1. What is the cofactor of -1? Well, we find that cofactor, right, of that. So let's see, what is that? We have, let's see, yeah. So it's 28 minus -6. So that's 34, and this is -34 because of the sign, right? Okay, now let's compute the last elements, the last 3. So the cofactor, what's the cofactor of -3? Well, the cofactor is this thing, right? So it's 2, 1, 3, -1. 2, 1, -3, and 1, right? Actually, it was the other way around. Okay, so that's, this one is a cofactor of -3. So let's compute that. We got -2. Oh, don't forget your sign. This is plus, minus, plus. So this is what? -2 minus 3, right? -2 minus 3, that's -5. So that's that entry here. And then we need to do, let me see if I can make it smaller so we can see it. What's next? The cofactor of 4. The cofactor of 4 is 7, 1, 0, -1. So this is -7 minus 0 is just -7. With a negative outside, it's +7. Next, this guy. What's next? 7, 2, 0, 3. So if you multiply this, you get 21, right? So this is the cofactor. This is a cofactor matrix, or the cofactor of matrix A. Now, let me make it bigger again. What happened? It's not working now? Okay. So now we need to find the transpose of matrix, of the cofactor matrix. The transpose of the cofactor matrix is the adjoint of A. Okay, so once I do the transpose, then I have the adjoint. So the transpose of this is column 1. Now it is row 1. Column 2 is now row 2. And column 3 now is row 3. So this is the transpose. So this is C transposed, right? Okay. What's next? What's next is we need to compute, right? So we need to find a determinant. We didn't do that yet. So we need to find a determinant of A. So what is a determinant of A? This guy is a determinant. So we can use arrows again, right? Let's use arrows. So this is what, or we can use a cofactor if you want. Okay, let's use a cofactor just to change a little bit. So I see a 0, so I'm gonna use plus, plus, minus, plus. So 7 times, right? I'm doing the cofactor method, right? This way. So 7 times, this is -6 minus -4. And then at 0, I don't need it because 0 times anything is 0. So this is gonna be -3 times, right? So I'm doing now this. So this is 2 times -1 is -2 minus 3, right? So this is what we have. So 7, -6 plus 4 minus 3 times -5. So this is 7, -2 minus, well, this one is going to be +15 now, right? And this is going to be -14. So what's the determinant? The determinant is 1, right? The determinant of this is 1. Now, what the formula said, in order to find a inverse, I need to do 1 over the determinant of A times the adjoint of A. So I know 1 over 1 is just 1, right? So whatever the adjoint is, that's the inverse, basically. So the adjoint is C transpose. So this is the adjoint. So if you won't multiply 1 times anything, that's not going to change anything. So this is A inverse now. So what's next? Now I need to multiply this A inverse. Remember, X equals A inverse times B. And if I multiply that, that will give me the values of X, Y, and Z. So what's, so I have that A inverse here. I just need to copy. And what I need to multiply by B, right? So what's B here? B is this guy. So we need to multiply that by B and we got the answer for this. So let's do that. I have to do the dot product. How many elements do you have here? This is a 3 by 3, and this is what? 3 rows, 1 column. Do the dimensions match? This match with this? Yes. What kind of solution you're gonna get? Well, or what kind of matrix you're gonna get? You're gonna get a 3 by 1, 3 rows, 1 column, and that's expected, right? Because that's a column vector. Okay, so let's use the dot product. Row 1, column 1, right? So this is -2 times 21 plus 8 times 5 plus -5 times -1, right? So if you compute this, you get -42 plus 40 minus, actually plus 5. So this is what? -2 plus 5, that's 3. So that means this equals 3, right? So now you need to do the dot product one more time. Now you do row 2 and the only column that you have, right? Row 2 column, well, column 1, you want to call it, whatever. So this is what? 3 times 21 plus -11 times 5 plus 7 times -1. Compute. So this is what? 40, 63. This is minus 55. This is minus 7. So this is going to be what? -8. Actually, positive 8. Minus 7, that's 1. Right? So that's 1. And what's next? Or what is the last step? I need to do row 3, column 1. Right? So let's compute. So this is 9 times 21 minus 34 times 5 plus 21 times -1. So let's compute this. So this is 189 minus 170. Well, actually, this is -21 now. So this is -189 minus 191. That's -2. So this is the solution to the system of equations, right? Let's check if this is true or not, because we can make mistake, or I can make mistake. So what was the original equation? Let's bring that here. Okay, let's do the other ways that we learn how to solve system of equations faster, right? If we can do it faster. Actually, I don't need to do this because I already have the answer. I think they did it. I think they solved it. Let's see what they have. I think they did it already. Let's see. Yeah, they did it. So this is their answer. Copy. So they have 3, 182. It's the same, right? I have the same. So I hope this video helps. I know that I took long, but I went over every single concept that we learned about these matrices, right? I covered the determinant, I covered the inverse of a 2 by 2, the inverse of a 3 by 3. I did the adjoint, I did the transpose. I talk about if a matrix is singular or not. That if it's singular if it's equal to 0. It's non-singular if it's not equal to 0. It's like if the matrix has an inverse, it's invertible, right? Those things, all these concepts, right? So make sure that you review this stuff. I will share the PDF file from this PDF, all these things I will share with you. If I forget for any reason, just remind me just in case, but this is it, okay? I hope you understand and have a good night.